We shall apply a few properties of factorization in this question. What do we do is we begin by taking or assuming the cube root of x over y equals to a, cube root of y over z equals to b, and cube root of z over x is equal to c. Now, if we cube both sides, we get x over y equals to a cube, y over z equals to b cube, and z over x is equal to c cube. Now, it's already given that cube root of x over y plus cube root of y over z plus cube root of z over x is equal to 0. That means if we plug in the values, we have a plus b plus c equals to 0. Now, from the properties of factorization, if a plus b plus c equals to 0, then a cube plus b cube plus c cube should be equal to 3abc. Now, we shall be using this property to simplify this further. So now a cube is x over y. We are plugging back the values, plus y over z plus z over x is equal to 3 times cube root of x over y times cube root of y over z times cube root of z over x. Now, if we take the LCM on the left hand side, the LCM will be x, y, z. So, for the first one, we shall have x square z, plus for the second one, we shall have y square x, plus for the third one we shall have z square y whole over x y z equals to 3 times. Now, whenever we have the same radicals, we can multiply the functions inside. So we have x over y times y over z times z over x. So now we have x square z plus x y square plus y z square over x y z, and that should be equal to 3 because everything that is under the cube root gives us 1 and the cube root of 1 is 1. And so we multiply both the sides with x y z, so we have x square z plus x y square plus y z square is equal to 3x y z, and that is our final answer. Thank you for watching.